We're going to talk about async sequences, and first of all, it's just an honor to be back in Japan, so thank you very much for inviting me back. Async sequences, not this year, but kind of new, and here you celebrate the new, but you also honor the past. And so I'm going to do that in this talk. We'll do both of these things. For the new, it's async sequence, and for the past, it's notifications. Notifications go back 25 years for macOS 10.0. So let's start with an example app. In this example app, we tap a button to send a notification, and then somewhere else we receive a notification and we display the result. And so we see something like this. When I tap the button, I'll reset the time to 0, and so the button is sending a notification, and somewhere I'm receiving it and updating the button. And the way this works is this: somewhere I have a sender, somewhere I have a receiver. The receiver has to register somehow, so it says, I'm interested in knowing when you send me something. And so once that happens, and the sender has something to send, maybe there's more than one receiver, maybe there's receivers everywhere, and the sender sends something, and you can see this duck emerging and being sent out, and everyone receives it. And so now you understand notifications. So in code, this looks like this. In code, I have this class, this sender, and we're going to post some updates every time that button is tapped. And so we create a notification, and the notification has a name, an object sending the notification, and it has this user info dictionary. And the user info dictionary can contain almost anything, these key value pairs. And that's part of the challenge that we're going to face when we get to async sequences later. Then we ask the notification center, you've created this notification, we post it, and now it's out there, and the receiver's ready to receive it. So let's look at receivers. The receiver's going to look inside that user info dictionary and pull out that timestamp and record it, and so the receiver's going to do that, and when I start things up, the receiver's going to start listening. And so when it starts listening, it does this. It says, hey, same notification center, can you add me as an observer? I'm listening for things that have this particular name coming from this particular sender. And the way we did it in the old days, the really old days, was something like this. We used a selector. And this goes all the way back to Objective-C. And so this pound selector that we use in Swift comes from this world of Objective-C, because you're basically sending the notification center a way to contact you and knowing what the message is it's going to send you. So here's the function, and because it's so old, we have to label it @obc. And inside the function, we reach inside and we get the information we need, and we set the timestamp. Now I want you to look at this code just for a second, because there's a lot going on here that's sort of unknown. Maybe the notification has a user info dictionary, maybe it doesn't. If it has a user info dictionary, maybe it has a key with this name, maybe it doesn't. And the value it retrieves, maybe it's a date, maybe it isn't. There's a lot of places where we're using this optionals. So Objective-C introduced blocks. It introduced GCD. Some of you are old enough to remember this. In Swift, these are closures. And so Notification Center, even though it was so old, decided it would update and embrace this new world. And so instead of doing it this way, it said, well, let's get rid of this selector, let's get rid of this callback, and instead we're going to change our point of view. Instead of calling back this method, we're going to take the body of this method, wrap it in a closure, and we're going to pass it to the notification center and tell the notification center, just do this. And so instead of being called back, we pass this forward, but notice the body is exactly the same as before. We're still looking inside the user info dictionary. Now, there was a minute, just a minute, if you blinked, you missed it, where we did combine. And the notification center people said, if this combine thing sticks around, we should embrace it. And so notification center learned to use combine. And so they changed so that we use the receiver this way. Instead of all this add observer and all that stuff, there's a publisher now. Combine was full of publishers and subscribers. And so this publisher would send out notifications. And when we receive a notification, we could map it by taking that notification and, oh my gosh, that's the same code we've seen before. And now a subscriber takes that date that's been filtered through and sets that to our timestamp. Now there were some details. We had to set this equal to a cancelable, and we had to make sure that we were on the main loop. But other than that, this code was pretty clean, and it's pretty neat that over all those years, we did notifications using delegates, using closures, and using combine. They all solve the same problem. We're interested in some source that sends 0 or more messages, and it does it over time. We don't know when that next button push is going to happen. And that's a problem that's been solved now with async sequences. And so async sequence replaces a lot of this code and does it in a really pretty way. Now you'd think in a talk of async sequences, where I'm almost quarter of the way through, I'd be ready to talk about async sequences, but I'm not. Let's talk about sequences first. So a sequence is a type that provides sequential iterated access to its elements. And you know sequences, but you might not have thought deeply about sequences, because a sequence is a protocol. And so if someone says, okay, go ahead and create a sequence, it turns out you can't. You can't say let X equal sequence and then instantiate one. Instead, what you do is you have to create an instance of a concrete type that conforms to sequence. You create an array, a set, a dictionary, anything that conforms to sequence. And so I again ask you, how do you create an array? And I again tell you, you can't. You don't create an array. You create an array of something. You can't create an array without telling me what the type is that this array is going to hold, because in Swift, an array is a value type. In Objective-C, it was a reference type, and so we were just holding pointers. It didn't matter. And so you create an array of ints, an array of strings, an array of dates, and we see this in code as you create an array that is generic in element. And so an array is a sequence has an element, and a type that provides sequential iterated access to its elements. That's how we think of a sequence, sequential iterated access. Oh, a sequence has an iterator. Let's look at this in code. Things are better in code. In code, I'll create an array that contains just these elements, and this is an array generic in int. It's an array of ints. And so I'd like an iterator for this, and so I ask the array, make me an iterator. Array make iterator gives me an iterator, and it turns out the iterator knows that it is handling ints as well. So I can ask the iterator for the next int. Give me the next element. And the type of next is really interesting. The signature is, it is something that returns an optional int. And so it returns 5, then 10, then 15, then 20, then nil. And when we hit nil, we know we're done. We've iterated through our whole array. And the coolest thing is that allows us to do something like this. If you've never used while let, it's one of my favorite things in Swift. If you know if let and guard let, while let is a while loop that will continue until you hit nil. And so this says, iterate through this array. When you hit nil, when you've run off the end of the array, that's when you stop. And so for now, we'll just print the element, and it'll do what we expect it to do. So this while let, you might want to use it, but it turns out you are using it without knowing you're using it, because we don't usually explicitly use while let. Instead of creating an iterator and using this while let, we use for. Underneath the covers, this for loop is using an iterator, it is using while let, but we write it this way and we think we know what it's doing. So that's a sequence. What happens if we move from a sequence to an async sequence? What changes? Well, now, this is a type that provides an asynchronous sequential iterated access to its elements. It's also a protocol. So how do you create an instance of an async sequence? Oh, it's the same hands. You can't. It's the same problem with creating an instance of a sequence. It's a protocol. I can't just say create me an async sequence. You create an instance of a concrete type that conforms to async sequence. And this is one of the magic things is async sequence was introduced to us a couple years ago, and more things are now conforming to async sequence and making our lives easier. The basic one is an async stream. An async stream is kind of the async equivalent of an array. It's sort of our workhorse here. So how do you create an async stream? By now you know the answer is you can't. You have to create an async stream of something. So an async stream of ints, of dates, of strings. The point is, an async stream, these things are flowing down there. Who's ever at the other end needs to know, well, what is it I'm waiting to catch? What is I'm going to pull out of the stream? And so we have an async stream, generic and element. So an async stream is an async sequence. It has an element, and it is a type that, as we've seen, provides asynchronous sequential iteration through its elements. And so it also has an iterator, but its iterator is an async iterator. Oh, Daniel, what's the difference between an iterator and an async iterator? I'm glad you asked. In code, let's create a stream. I'm not going to show you how now. I'll show you before the end of this talk. But let's just assume it's a stream that eventually contains 5, then 10, then 15, then 20, and then it's done. So I have some sort of an async stream, and so I have an async stream in this case of ints. Let's make an iterator. This time we make an async iterator, and we get an async iterator that knows how to iterate through ints. And so now I use my while let again. This looks exactly like before. Unfortunately, it doesn't compile. And if you've paid attention to my slides so far, you know there's that empty space there. Something's going to fill that in a second. And the point is, in this case, in the case of an async iterator, the next method still returns an optional int, but this time it is asynchronous. And so when we call it, we need to call it with an await. And so that's where the while let element equals await. And as before, we don't tend to create these iterators explicitly, and we don't use the while let explicitly. Instead, we use this for, and that's where the for await comes from, because the next is something that is asynchronous. So for await element in stream. Isn't that the prettiest thing? I just love this API. So Notification Center, 25 years old, looked at this new thing and said, well, we'll support async sequence. And so we'll support async sequence, but we've got a problem. And the problem is notifications are really old, and they're reference types. And they contain this user info dictionary that can contain anything. That's not going to be safe to send across these actor domains. So I need to make changes in both the sender and the receiver. And the reason is, as I said, notification is a class. User info can contain anything. And so in this case, it's containing this date, but in general, notification is not sendable. And because notification is not sendable, we have to pay attention to it because it's going to cross actor boundaries. You don't want to be on the main thread when you're listening. You want to do things in the background, and then you want to be able to push to the main thread. So you're crossing actor boundaries with these things. And so the trick is we now can create a value type. And this is fairly new in Swift. It's a new type that can be converted to and from a notification. And I'm not going to show you that conversion here, but I do want to show you how we use this type. So this type is, in this case, an async message. You can send an async message, or you can send one on the main thread, on the main actor. In this case, I'm calling it date update. It's of this new type. And so instead of having a user info dictionary, we just add properties. This just looks like a regular Swift type. And so I've got this struct that contains this value type. This is sendable. This is really safe. Now I need to also specify what type the sender is. And so the subject is of type sender. And this allows me to post an async message fairly simply. I post an update. I don't have to create this notification. I just create an instance of this guy. And now when I post the notification, I also specify the sender isn't just of type sender. It is this instance of sender. And now we can go back to the receiver. And when we started listening, we have this API, which is just delightful. It's listen for messages of this type. And it turns out these messages are an async sequence. And they're an async sequence of this date update, this thing that we're sending across. And so we're just listening to these guys, and so we for-await them. And as each message comes in, don't know when, it's asynchronous, I just set the timestamp equal to message.value. None of this reach inside a dictionary, see if it has a key, do all that optional stuff. This is delightful. The API that was so old is getting freshed again. So, in addition to Notification Center, other APIs use async sequence. For example, there are properties in observables. So if you use an observable type, you can observe specific properties. So I'm going to make the sender observable in this case. Here the sender is observable, and I have my timestamp, and so that means that people can listen for changes to the sender timestamp. And so I just post an update this way. Isn't that nice? That's all I do. And so now it's time for someone to listen for changes to the sender timestamp, and we do that in the receiver. So I'll start listening here, and there's a new thing called observations. Observations allow us to say, I'm interested in this property and changes to this specific property. And so what I get is I get an async sequence of optional dates. No ceremony, no hard time, that's all I do. And you know once you have an async sequence, you just for-await. And so that's observations. It's a new async sequence. Finally, I promised you we'd create a stream. And so let's create a stream in the sender. So I go back to the sender, and it's got all this observable stuff. Let's get rid of it. And I'm going to create a new async stream. An async stream has two pieces. It has the stream, which you're going to want to consume, and it has a continuation. And a continuation is how I put things into the stream. And so in my time when I post an update, every time there's something to post, I'll say continuation yield, and I'll put this in there. So every time someone taps the button, my continuation will add this to the stream. You can imagine this as like a little slide where we're dropping dates in and they float down the stream. Now, this resumes the person listening. This resumes the for-await and says, here's a new value for you. What happens if we've run off the edge and there are no more values to come? Then we can tell the continuation to send the finish message. Finish resumes and sends nil, and the while-let, the for-await, sees the nil and says, I'm done listening. But let's not finish. We'll just use the yield and pass a date. By now, you can write the receiver. You go back to the receiver and you say, well, instead of all this observation stuff, I can get rid of that. I'm just listening to the sender stream. The sender stream is an async sequence of dates. And so I still for-await it. And so async sequence solves so many issues for us. We've looked at notifications through the ages. We looked at notification and async sequence. We looked at the meaning of an async sequence, and we looked at the mechanics of an async sequence. And most important, because other people will create async sequences for you, we looked at how we consume an async sequence. And examples like observable, or creating our own async stream. And so those are the fundamentals of async sequence. Thank you.